Now let us discuss the continuity equation in a three-dimensional. To derive this equation, let us consider a fluid element which is having three directions. A, B, C, this is one face. A dash, B dash, C dash, D dash. This is another face. Length of this element in x direction is dx. Length of this element in y direction is dy. Okay. Length of element in z direction is dz. This is x coordinate, y coordinate, z and y. X axis, y axis, z axis. So, being it is a y axis, length is represented with the y terms. Being it is x axis, its length is represented with the x terms. Being it is z axis, its length is represented with the z terms. Dz, dx, dy, dz. Okay. So value of the element is length into breadth into height. Okay, dx, dy, dz. Now let us consider u is the velocity of the fluid in a u is velocity of fluid in a x direction. Okay, v is the velocity of fluid in a y direction. W is the velocity of the fluid in the z direction. Okay. General phenomena representing the velocities of fluid in x direction, y direction, and z direction. Why we are considering this? We are going to derive this continuity equation in three dimensions or three directions, and rho is the density of the fluid. Density of the fluid. Okay. Now U V W. This is the representation of velocities. Okay, with which velocity it may live? So fluid will live in this way, with certain velocity, in this certain velocity, and in this certain velocity. As the step by step we will discuss it. Okay. Now let us consider mass current of fluid passing through this phase A, B, C, D. Okay. Flow of fluid in the direction or simply x direction. through phase A, B, C, D. Phase A, B, C, D. So from continuity equation, it is then right. What is that? Rho into area into velocity. Velocity. Okay. Rho is a density. Rho is a density. Area. It is having coordinates. This one and this one. Length into height. So what is this? dy dz. Okay. Velocity in x direction is u. So what we can write? Rho u dy dz. Rho u dy dz. Understand? The fluid entering we can write. Okay. Next, the fluid leaving from phase. What is this phase? A dash, B dash, C dash, D dash. A dash, B dash, C dash. In same x direction. X direction. So what is this? Rho into u into du dz plus dou y dou x into rho u into dy dz dx. This is the variation of fluid flow along the x direction for the length of dx. Understand? See, if you consider only this term, the variation of fluid flow in x direction for unit length. How many times we are considering dx? That is why we are multiplying dx with the dx. Understand? Now consider net gain in the fluid flow in the x direction. What is this? Understand? Treat it as equation 1 and equation 2. This is equal to equation 1 minus equation 2. Rho u dy dz minus this one. Rho u dy dz. Okay. Plus dou y dou x into rho u dy dz into dx. We can cancel this term because these are the two terms. So what is the remainder thing? What is the remainder? So minus sign follows for here. Minus into plus minus. Dou y dou x into rho into u into take these three terms out. dx dy dz. dx dy dz. So what are the terms connected in this? Take gain in the fluid flow in x direction. Dou y dou x into rho u into dx dy dz. So what are the common phenomena we are seeing? Being it is x direction, so we got dou by dou x. Being it is x direction, we got the velocity component u. Density is a constant, and this is a fluid element. Okay, write it as equation 3. Understand? Similarly, we can write the net gain in the fluid flow in the y direction. This is equal to minus dou by dou y into density rho into what is the velocity component in y direction? V into what is the value of the fluid element? Take it as equation 4. Similarly, net gain in fluid flow in z direction. Okay. What is this? Minus tau by tau z. Meaning it is z direction. And density hc. W is the velocity component. Velocity component in z direction. Similarly, velocity. Value of the fluid element dx, dy, dz. Assume this equation as 5. Okay, we have net gain in fluid flow in x direction, net gain in fluid flow in y direction, net gain in fluid flow in the z direction. Now consider total gain in the fluid flow. Total gain in fluid flow. So it's nothing but summation of equation 3 plus equation 4 plus equation 5. So what is minus rho by rho x rho u dx dy dz minus rho by rho y rho v rho x by dx dy dz and minus rho by rho z rho w dx dy dz. So what are the common terms? Minus is the common term. Next what is the common term? dx and dy dz. So rho by rho x rho u plus rho by rho v plus rho by rho z rho w all into dx dy dz. Okay. What is this? Total gain in fluid flow. Assume it as equation 6. Total gain. Okay. And next we know that density rho is equal to mass by volume, is equal to m by v volume. Okay, mass is equal to density into volume. As the fluid is flowing, we have to consider time. So if the density varies, we will consider dou rho by dou t. This is the variation of density with respect to the time. Value. What is the value of the fluid? Okay. For this fluid element. For this fluid element, dou rho by dou t is the variation of density with respect to time into what is the value? dx dy dz. Okay. So we can, this is nothing but mass flow rate of fluid of density rho of volume dx dy dz. This is equal to dou rho by dou t into dx dy dz. Assume it as equation 7. conservation of mass equation 6 is equal to equation 7, because this is the total gain in mass flow rate and this is the mass flow rate of the fluid through element or value dx, dy, dz. So what is this? What is the equation 6? This one minus dou by dou x rho u plus dou by dou y dou v plus dou y dou z dou w. Okay, is equal to this equation 7 dou rho by dou t into dx dy dz is equal to equation 7 dou rho by dou t dx dy dz. In these two equations, what are the common terms? Value dx dy dz. Cancel the same term on left side and the right side of the equation. So what are the remainders? Minus dou by dou x into rho u plus dou y dou v plus dou y dou z into rho w is equal to dou rho by dou t. Take this left hand term to the right side of the equation. Dou rho by dou t plus is equal to 0. This is the continuity equation for any fluid flow in 3 dimensions. In this way, we can derive it. This continuity equation can be applied for steady flow, unsteady flow, one-dimensional flow, two-dimensional flow, incompressible flow, or compressible flow. Let us see one by one cases. For incompressible fluid flow, dou rho by dou t is equal to 0, because density is constant for composite fluid flow. Therefore, continuity equation is dou by dou t plus this is 0 plus dou by dou x rho u plus rho v by dou y plus rho w by dou z. Okay, we can write it as dou by dou x plus dou by dou y into v plus dou w by dou z into rho is equal to 0. Okay, similarly, dou u by dou x plus dou v by dou y plus dou w by dou z is equal to 0. Okay, for incompressible fluid flow and for 3-dimensional flow, continuity equation is this one: dou u by dou x plus dou v by dou y plus dou w by dou z is equal to 0. Similarly, this equation can also be reduced into one-dimensional, two-dimensional, three-dimensional. Case 1, already case 1 over. Case 2, incompressible two-dimensional flow. You can consider only two, either u x and y or y and z incompressible one-dimensional flow. Dou u by dou x is equal to 0, or dou v by dou y is equal to 0, or dou v by dou z is equal to 0. In this way, we can derive continuity equation for the three-dimensional fluid. Thank you.